guys, welcome to another episode of MrLopezClasses.com. We are going to continue with our course of Introduction to Marine Engineering, and yes, we are in the chapter dedicated to fasteners. And today we are going to continue with the bolts, screws, and hardware commonly used in marine applications. And now, guys, we are going to continue with the fasteners, and we are going to check quickly the definition of fastener. A fastener is a hardware device that mechanically joins one or more objects together. That's simple. And we are going to try to check the difference between a screw, like this, and between a bolt or a stud. And this is a big difference. The screw is used in wood, is used in plastic, is used in composite materials, the screws. The bolt and the studs, they have thread, fine thread or coarse thread, that we are going to talk later. Depending of the thread, the bolt is used. In other words, the bolt and the studs are preferably for metals, for soft metals and hard metals. We are going to study later, in the next coming chapter, the difference in between soft metal and hard metals, the difference between non-ferrous alloys and ferrous alloys. It's a big difference, important difference. Yes, my friends, with the bolts, you need to do the thread. And we are going to explain in this chapter the procedure to do threads and the procedure to repair threads, right? Okay, that's the main difference between screws and bolts. Other important difference is on the screws, the pitch. What is the pitch? We are going to talk later about that. What is the pitch of the propeller? Normally the people say, no, it's the angle of the blade. No. The pitch is how much distance advance the propeller in one complete revolution. We are going to study in the next chapter that definition. Exactly the same with the screw. What is the pitch of that screw? Is how much the screw advance in one complete revolution. Oh, of course, the screw have a bigger pitch in comparison with a bolt fine thread or a bolt coarse thread. In between the fine and the coarse thread have a bigger pitch, advance more in one complete revolution. Yes, that's other difference in between screws and bolts. And be careful with that. I found a lot of equipments that the students, the technicians, destroyed because tried to fix it with screws, holes that originally are for metric fine thread or coarse thread. And they tried to introduce a screw over there. The screws are not for metals. In general, are for wood, for plastics, for composite materials, no metals. For metals, normally are bolts and studs. For that reason, we need to be careful with that definition. Yes, a screw or bolt is a type of fastener characterized by helical ridge. Alright, and this is in the bottom, in that corner, the difference between screws and bolts. And bolt, screw, and stud. Yes, in the next explanation with Mr. Rodriguez, we are going to explain the main difference between both of them. There are different types of wood screws. For example, that one. If you see that one, is a flat head, Phillips flat head. And the bottom one is oval head. It's a flat head, oval. Depending on the situation, all of those screws should be zero corrosion. In other words, the quality of the alloy should be excellent to avoid corrosion. In general, we are going to use in the future for stainless steels, we are going to use stainless steel series 300. The series 300, 304, 316 are the perfect alloys for stainless steel authorized in marine application, series 300. Okay, be careful with that. And the same with the copper. The copper alloys should be series 5000. 5000 are the alloys authorized for copper alloys. Okay, my friends, don't forget, we are going to analyze in the next coming chapter about materials, those alloys, the alloys for stainless steels, and the alloys for copper authorized for marine application. Not all the copper alloys are good for marine environments. Exactly the same that not all the aluminum alloys are good in marine environments. There are aluminum alloys not good for marine purposes, and there are copper alloys not good for marine purposes. We are going to check that difference carefully, because this is the secret. If you want to be a great engineer, a great manager in a marina, you need to keep in your pocket a magnet in order to identify if the stainless steel is appropriate. When the stainless steel is good stainless steel, marine grade stainless steel, when you approximate the magnet, nothing. It's not magnetic. If the stainless steel is medium grade, is not properly marine grade, the magnet attracts the metal, and that's not good. Alright, in the next coming episode, with the part of the episode with Mr. Rodriguez, we are going to explain that difference in between one and the other one. Those are the typical wood screws, and those are machine screws. As you see, it's basically on the thread. You see the thread? The thread could be fine or coarse thread, and we are going to explain later what is the meaning of that. And in this particular, the top one is oval head. It's a Phillips oval head, and the bottom one is a flat head, and it should be used with a flat screwdriver, depending of the screwdriver, flat head or Phillips as a screwdriver. And look at this. This is a special situation. This is a screw that can be used in metals. In metals, normally the appliance use those type of screws. Those are sheet metal screws, fully threaded screws with a point for use in metal, in sheet metal. Yes, the point at the end helps to introduce the screw on the metal. It's commonly used in the cover of air conditioning equipment, in the cover of appliance. Yeah, be careful. We can use those if the material is marine material. You approximate the magnet, and if the magnet no attract the screw, it's because the screw is good stainless steel. The magnet is the secret. All right, be careful. Keep a good magnet in your pocket in order to verify the quality of those screws. And this is other nice type of screws. Those screws at the end, they have like a tab to do the thread. Those screws are double function. Is not commonly used in marine applications, but in some industrial application is used. Thread cutting machine screws. Yeah, with thread cutting at the end. Yeah, that's good. No, they do the thread by itself. It's not commonly used in marine application. And this one, the self drilling screws, are used in a lot of air conditioning equipment. Water makers, they use those screws because they do the hole and immediately enter. It's for sheet metal, and once again, you can use those screws if the screws are marine grade 300 series, 300, 304, 316, 302. If it's 300 series, is marine approved. If not, no. How can you verify that? With the magnet. You approximate the magnet and you verify if it's fully zero corrosion, or if it's medium, or is pure steel. You need that those screws, those bolts should be 100% zero corrosion. Okay, and this is the typical bolts that we are going to use in different applications on engines, transmissions, the hex bolts or hexagonal bolts. It's because the head is an hexagonal, and those bolts are widely used in marine applications. We are going to use a lot of those bolts, marine grade. In the engine, internally in the engine, there are a lot of bolts, not necessarily marine grade. because internally in the engine the environment is surrounded with oil, and the bolts are submerged in the oil, and they don't need to be marine grade. All right, marine grade is when the screw is exposed to the environment, to the salt, to the marine environment. This is other type of bolts commonly used is the carriage bolts. You remember those bolts in the bumper of your cars? Yeah, it's commonly used, but it's also used in the struts on the propulsion system. And the bolts to fix the struts, those are carriage bolts, because they have less resistance with the flow of the water, because the head is oval and produce less resistance to the flow of the water, especially in the struts. Yeah, we are going to talk in the chapter 4, I think so, about the propulsion system, and we are going to talk about this type of bolts, carriage bolts, used on the propulsion system, especially to fix the struts. The lag bolts. Right now in the micro video with Mr. Rodriguez, we are going to explain those lag bolts. They are commonly used to fix the motor mounts, the engine motor mounts, to fix the engine motor mounts, and they are very, very commonly used. Okay, those bolts should be also marine grade, no galvanized. The galvanized material is no good for marine application. Right now, Mr. Rodriguez and me, we are going to explain the difference between galvanized material and properly stainless steel, marine grade stainless steel. The lag bolts are used to fix the motor mounts into the stringer of the boat. And there are different type of Allen head, the Allen head. And yes, we are going to explain in the next coming part of the episode. Use the Allen keys appropriated for that head. If the Allen key have a little play, this is not the Allen key recommended for that bolt. You need check in the other system. Probably if that Allen key is standard, probably the similar Allen key in metric fix it better. Oh yeah, no play. Be careful. If you have a little play, this is not the key for that bolt, and you damage the head. You damage the head of the bolt, and finito. You can spend weeks trying to remove one bolt. In marine situations, in some cases you don't have room. You don't have room for access. Only you can introduce your hand, and only with your hand you need remove an start motor or replace an alternator, because no space. The engine rooms are pretty close, and you don't have enough room to work. Be careful when you select the wrenches, the socket, the Allen keys for this type of bolt, because if you damage the head of the bolt, this is catastrophic. Believe me, it's catastrophic. For that reason, you need to clean the head of the bolt properly and apply the key appropriated for that bolt. Allen head bolts are very, very commonly used. Set screws. We are going to use a lot of set screws in this book. We are going to explain the propulsion system, and we are going to explain the installation of the coupling, the shaft, the propeller, and the bearings. And in this particular example, we are going to use set screws in order to install the bellows into the stuffing box. This is one important chapter, the chapter dedicated to the propulsion system. And we are going to analyze in detail, and we are going to use a lot of set screws. The set screws are used to fix movable parts with shafts, basically. But once again, those set screws should be in a stainless steel, in a marine grade stainless steel. There are a lot of set screws used. In this particular case, this is the riser of a manifold, and they are used in different applications. In millions of applications in marine applications, we use set screws. U-bolts, you remember, on the trailer, or in your car, in the exhaust pipes. In marine applications, are used to fix the pipes, fuel lines, hydraulic lines. with U-bolts, and also on the trailers. On the trailer, it's commonly that the people use zinc galvanized material. The galvanized material is not allowed in marine applications because the galvanized system is with zinc, and I am going to explain later what happened with the zinc. The zinc attract the oxygen, and that's not good. Right? For that reason, we are going to try to avoid use galvanized system. And yes, we are going to use a lot of drilled end bolt. For example, in the next chapter, we are going to explain the procedure to install the propeller, remove the propeller, and install the cutter pin. And those cutter pins enter on the drill at the end. That drill and cutter pin. And safety wires, the installation of safety wires. I am going to explain the procedure to install safety wires on the drill head bolt. We are going to pass the safety wire and tie the safety wire on the drill head bolts. And yes, a different type of sockets for head with the 12 points and socket for head with the 6 points. And be careful, select the socket appropriate, especially in those bolts, the 12 points bolts on the head. You need to be careful with the selection of the socket. If not, you damage the head of the bolt and finito. My friend, if the bolt have a little play, if the socket have a little play with the head of the bolt, this is not the socket appropriate. Don't try. If you apply force, you rounded the head of the bolt and finito. This is a big problem. You need to be 100% sure that you don't have play on the head of the bolt. Okay, no play, zero play. Now you apply the torque slowly back and forward until you feel that the ball starts to move. Not try to apply all the force at the beginning because you ruin the head of the ball. In this business, you need to be most patient, like we are going to explain with Mr. Rodriguez in the next coming episodes. Yes, and we are going to use a lot of washers. There are washers integrated with the head of the bolts, like those bolts in transmissions, in carburetors. It's very common. Okay, for that reason, this is the hexagonal, the head nuts. Always use nuts and bolts, marine grade series 300. This is the series ABYC question. What is the series authorized for marine application in stainless steel? Series 300. I'm going to explain what is the meaning of series 300, what is the element, the component of the alloy that produce the anti-corrosive properties. Okay, my friends, yes, this is the procedure to install the safety wires. We are going to use safety wires in the chapter of propulsion system. I am going to explain the procedure to install the safety wire. With the pliers, we are going to install the safety wire in a couple of bolts, and yes, we are going to learn that procedure. And probably when you visit the shop, in the laboratory, I explain again the procedure to install the safety wire on bolts when the head is drilled. Alright, and the wing nuts, we are going to explain later. The wing nuts are not authorized in marine application. To most people install the battery cable, the battery terminals with wing nuts. The wing nuts are not authorized. I think so that probably in small boats probably, but in medium and big boats no. Alright, for that reason I prefer that you keep in mind that the wing nuts are not authorized. No wing nuts. Under any condition install wing nuts. For that reason, we are going to check right now with Mr. Rodriguez the procedure to select the fasteners and what type of fastener is better depending on the situation, and how can we use the different type of bolts and screws. In this episode, we are going to talk different topic of future courses. But in general, the enemy in marine installations is the corrosion.
Absolutely. You gotta use the right hardware for the proper application.
You hear the right hardware according with the application. And depend where should be located the equipment, you need to select appropriate the material.
Absolutely.
The material, because we are working in a marine environment.
The marine environment is unforgiving. Absolutely. And you'll see later on in the courses the different corrosions that could present by not using the correct dissimilar metals.
Dissimilar metals in contact with the salt water produce different type of corrosion: poultice corrosion, galvanic corrosion, electrolytic corrosion. We are going to study a lot of corrosion in one course dedicated exclusive for corrosion. For that reason, what is a good technique to identify if it's a good stainless steel or not good stainless steel?
When in doubt, use a magnet.
The magnet.
Magnet's your best friend. So, like this one here is a good stainless steel. It doesn't grab, right?
No grab.
This one here is somewhat a good stainless steel.
A little, okay?
And if it's not stainless steel,
oh yeah, that's nothing. Look at this, my friends. Externally, it's too hard, no?
it's hard.
This is galvanized. Galvanized in marine application is the enemy because it's covered with zinc, and the zinc attracts the oxygen.
Absolutely.
In marine application, this is not good. This is the enemy. No galvanized pieces of nothing in marine applications.
The only galvanized you should have is on your trailer.
On the trailer, that's it.
That's it, because it has more integrity.
Correct.
And here's another bolt that's
other
not.
bolt that. That's not good. This is not good. For that reason, a good inspector in this business need a magnet in the pocket.
Yeah, I'm sorry, go ahead.
No. Oh, I finished the installation of the air conditioner. Let me check. Those bolts are not good. Magnet. Replace that. Oh, no. Loose like a stainless steel, but it's not a stainless steel.
And there's different grades of stainless steel.
Of
you have
course.
304, 316. The only one you should really use is 316 in the marine environment.
Don't forget this in the future. In marine application, you need a stainless steel series 300. 304, 302, 316. All of those are accepted marine grade series stainless steel. And for the copper alloys is series 5000.
Right.
Those are the alloys appropriated. Okay. We have a different type of bolts depend on the application, but once again, my friends, be careful with the head of the bolts. You damage the head of the bolts and you
create another problem.
Yeah, you create another.
You create more work for yourself.
Yeah, more work.
And you probably make the guy, the service manager, upset because it was unnecessary to damage that bolt if you used the proper tool.
Correct. Never use loose socket, loose wrenches. Use the appropriate wrenches, exactly the wrench. Oh, it's a little loose. Check in the other. It's metric. Check in a standard, or vice versa.
Right.
That's the most important part. And other important thing is, depend of the application, select the appropriate bolt. For example, Danny, what type of bolt is this? That type of a screw?
This is actually a lag bolt.
Lag bolt. Where is used?
This is going to use hold the motor mounts to the stringer.
On the stringer.
Yeah.
Oh, yeah, I remember that. You know when the stringers are damaged, what happened with this bolt?
It'll pull right out, it'll twist.
Because internally the stringer is hollow because absorb humidity and the foam is gone. We are going to repair a stringer. We are going to replace stringers in our class of composite materials.
Yeah, we'll be learning how to make stringers.
And we are going to replace that worst scenario with the foam internally. We are going to replace for wood or for metal. No?
Right. Yeah, because some motor mounts, in depending on the application, they'll put aluminum 90-degree angle, either stainless
like
or heavy-duty aluminum.
Correct.
And then they'll mount that on there, and it'll be lagged in or through-bolted through the stringer.
Correct. And my friends, be careful with the material. We have a different type of applications and different type of alloys used in this marine business. Danny, in general, we are all the time we talk about the fine threads, coarse threads, and depending
on the application.
Depending on the application.
Correct.
For that reason, you need to be familiarized with the meaning of fine threads and coarse threads, and the meaning of metric and standard. We are going to review quickly. We have threads metric and threads standard. In metric, both of them, they have three digits.
3 digits.
For
correct.
the specification. The first one, we are going to talk right now about metric. The first one is the diameter. The diameter, for example, this is metric, and is the diameter. This is the first digit. The second one is the distance in between two consecutive threads. And the last one is the length of the bolt. That's for metric. For a standard, like this. The first one is, once again, the diameter in inches. In the previous one is the diameter in millimeters. This one is in inches. The second one is how many threads you have per inch.
Per inch.
And the last one is the length of the bolt. Both of them are pretty similar. The difference is in the middle number. The middle number in metric is the distance in between two consecutive threads in millimeters. And in a standard, the middle one is how many threads you have per inch. Finito. How you know easily if one thread is coarse thread or fine thread?
Well, the coarse thread, you can definitely see the distance between.
It's bigger.
It's bigger.
No? It's bigger.
That's a coarse thread there.
Correct. Exactly. That one is coarse. It's big.
And this is a fine thread.
And this is fine. No.
Right.
That's fine.
Correct.
Like this, we have a coarse and fine. And what happened when you try to introduce a fine bolt?
Well, you damage the threads on the bolt, and you can damage the nut.
Correct.
Or damage if you're putting it in the engine, you can damage the engine.
Correct.
And then you're going to have to use a tool to read through the threads.
Yeah, and this is one of the laboratories that we are going to do. We are going to explain in the laboratory the procedure to repair threads. We are going to use the taps and the dies. Right now we are going to talk about that. And we are going to insert helicoils.
Yeah, no? Helicoils, you're going to tap and you're going to do a die. You guys are going to learn tools that you need.
Yes, my friend. You need keep a good set of taps and dies. What is the difference between this?
Well, what could be the diameter and the thread type?
Correct. And the die is used to do the thread in a bolt. No?
To fix the thread in the bolt.
With the die. And with the tap, you do the thread in a hole. The tap is the male, and the die is the female. Okay? One to do threads on holes, and the other one to do the threads on shafts. We are going to repair threads in the shop. How? We are going to pass again the tap, or we are going to pass again the die, or
they also sell these tools that have threads on them. Okay, different threads, different depending on the application. So obviously there's coarse, fine, metric, and standard. So what you do is you put the bolt in a vice grip, and a vice grip in a vice, and you can work the thread. This is not this here is only specifically like if you damage the beginning threads. It's really not to fix the whole entire thing. If you're gonna fix the whole entire thing, you would use these.
Let me explain something. This tool is excellent. Normally, when you damage the thread of a bolt, you damage the first, the second one, the third thread at the beginning, and with this you can fix it. You can fix it those grooves, no?
Yep.
And you recover the bolt. Yes, the only that you need in this business is patience.
Patience, absolutely.
A lot of patience, because to repair the thread of a bolt, you need a lot of patience.
Yes.
Yeah.
And you know what's nice about these is this you can carry in your toolbox instead of carrying the whole entire thing. So you're on the field and you damage the thread a little because you weren't paying attention. You could actually fix the threads with these as long as you don't really just. I mean, listen, guys. If you're screwing a bolt and it doesn't go, there's a problem. So you don't just keep going. You have to take it back out and check the threads are correct.
Correct.
You know?
And in the lab, we are going to practice doing threads in different type of metals, soft metal and hard metal.
Hard metal, absolutely.
We are going to practice with a piece of aluminum, and we are going to practice with a piece of steel. And remember, when you use the taps, there are three types of taps: the conic, semi-conic, and straight. At the beginning, it's good idea pass the conic because it's conic.
Right.
It's easy.
It kind of lines everything up.
Correct.
Right.
And when you finish with the conic, you pass the second one, semi-conic. And when you finish with the second one, you pass the straight. And right now the thread is perfect. This is the properly way to do a thread using those three. When you have a hole, each hole have three different type of tabs: semi-conic, conic, semi-conic, and straight. But those three. And this is the procedure we are going to practice on the laboratory to do that project. Other project that we are going to do is insert the helicoids.
Correct.
When the thread is completely damaged, the only solution is make a bigger drill and install a helicoid. And yes, we are going to do that process in the laboratory.
And the good thing is when you get a good tap and die set, it'll come with the drill bits. And it'll tell you the size, what you need for what you're looking for, so it takes the guessing out of the way.
The different type of drill bits.
Right.
This is a professional set.
This is a professional set.
It's for both of them, for metric and standard.
Oh, this does everything.
And for fine and coarse thread. Yes, my friend, you need a good quality taps and die set for fine, coarse, metric, and standard. And of course, with the drill bits.
Yeah. You need the drill bits, the Home Depot drill bits.
No, that's not good.
No, you need to get carbide, titanium, the black and gold. They're like $200-300 for the drill set. But let me explain something to you. What happens when you use a cheap drill bit? You use a cheap drill bit and it breaks in the component, you're really in trouble, because there's nothing harder than a drill bit to get out. So it's important to use good quality drill bits.
Only for information, and we found that in the market 3 colors of drill bits.
Right.
The black ones,
the black and gold they call,
the yellow ones, and
titanium.
the white ones, like a steel color.
Cobalt. So I think this one's the cobalt.
Correct.
There's cobalt, titanium, and then you have the black and gold.
Correct. The black ones are used for what type of?
That's for hard metal.
Hard metal. The yellow ones.
The yellow ones for soft metal.
The yellow one for aluminum, for plastic, for soft metals. And the other one,
cobalt you can use for stainless steel, and you can use for hard metal too. But
for hard metal.
But the black and gold is the strongest one.
Correct. It's clear, my friends. And other difference is in the point.
Yeah.
This one is for metals, and the other one with that point is for wood and plastic. Never use those drill bits in metals because you break your hand.
It'll twist your wrist.
Be careful with that. That's dangerous.
Yes, absolutely.
All right, and the selection of the drill bits is critical. Once again, never use those drill bits in metals.
Yeah, you're not using a concrete drill bit.
Oh,
you gotta use the specific drill bits for the application. If you don't do that, you only create a problem for yourself.
Those are concrete drills. If we found one of those drill bits in your toolbox, we put on the garbage. We put on the garbage all the toolbox.
Correct.
All right, now this is serious because this is a serious business. You know that this boat is the toy of a rich guy. What happens if you destroy that toy?
No, you're gonna be pissed.
Yeah, no.
And you create a big problem.
Yeah, of course. When you visit a boat, you need enter properly, organize it with good tools. Today, the majority of the customers they have cameras, and they see the boat all the time in the cell phone. When you visit a boat, you need be clear, organized, professional with the professional tools. Any other information?
Well, on the drill bits, you also have left-hand drill bits.
Oh yeah,
Okay?
yeah.
So left-hand drill bits, the only time you use that, like if you broke a bolt and you had to drill it out, think about it. If you're using a right-hand drill bit, all you're doing is you're pushing the bolt in. When you're using a left-hand drill bit, it's constantly trying to extract it out. In some cases, they'll come right out with the drill, which that's the best case scenario. But in most cases, it doesn't quite work out that way. But once you drill a hole out, then you get it to a certain size. Depending on the bolt, you have different extractors. You have one that's kind of like this.
This extractor is when the head of the bolt is broken
flush.
You make a small hole with a drill bit. You introduce that one. You punch it a little, and after that, you remove the bolt
and use heat.
Oh,
absolutely, use heat. Now you have that version, and then you also have this style version. So you have an idea here. This one's still stuck on here. This one was broken off in there. We drilled it, and we were able to extract it. It's still on there. But this is exactly what it looks like.
Once again, the helicoid is in the opposite direction.
Right.
Yeah. For that reason, when you twist it counterclock, you remove it.
Absolutely.
Yeah, but you need a lot of patience. when you use extractors, and you need practice. The only way to learn is practice. Hey, you have an outboard in the backyard of your home abandoned. Remove the bolts and try to remove the bolts with extractors. That's the only way. That's the only way to learn.
Because this is something you'll use all the time. Because especially being in the marine industry, between corrosion, the boat, one corrosion, and not only that, it freezes, the bolts freeze in there. Sometimes, even if you heat it, sometimes it breaks and you have to extract.
Correct.
This is a skill that you're constantly going to use. It's not like this is a one-time deal. No, this is something throughout your whole career you'll be using this.
Correct. Once again, tools, more tools, every day more tools. In this particular example, you need a good set of taps and dies, a good set of extractors, male and female extractors, because in some cases you need to remove the bolt, in some cases you need to remove the nut.
And when you're doing the tap, you don't just keep cranking. You have to go back and forth, back and forth. When you go back in, you go a little bit more. You go back out.
And you return back and return.
Because what happens is you don't want to break that tap in there because it's a hard steel, just like a drill bit. So it's important that when you're doing that you go in it, and I usually use some kind of penetrating fluid just to kind of help it, and then you just go back and forth until you go all the way in, and then once it goes all the way in, you take it back out, and I usually clean the tap, and I'll do it one more time to make sure everything's good.
For that reason, the project is we are going to give to you a couple of bolts, one ball standard, other ball metric, and you need to select the appropriate tap, and in different type of materials, aluminum or steel, you do the thread for both bolts. And after that, we are going to give to you a piece of
actually we got some lower units there. We'll just drill holes through
exactly,
and, just tap
and you need to repair the thread and install helicoids in that unit. This is the first project. And the second project, we are going to supply a piece of aluminum, and you need only with files, only with hand saw, and sandpaper and the caliper, you need to fabricate a couple of dies like this. It should be perfect, equals.
It has to be equal all sides.
All the sides. We are going to verify with the micrometer if the cubic is perfect, and the external dimension of both of them should be exactly the same. This is the second project. It's a nice project.
Yeah, it's a fun project.
Okay, we are going to use the tools. We are going to use hand tools, because in this business we need hand tools all the time, because we are in the middle of the ocean, the key is broken, the key fall on the water, and you need to solve it. You need to fabricate the key again. How many times you need to fabricate pieces?
A lot of times.
A lot of times.
Especially if you're in an area you can't get one.
Yeah.
Like again, you might be going to the Bahamas. We get flown to the Bahamas every once in a while to do repairs. It's not like I have everything available. It's not like when you're at your shop, you get everything here.
Correct.
So you got to anticipate certain things. So you may need to fabricate something to make it work. Just like gaskets. You don't have a gasket, you fabricate a gasket.
This is another project. We are going to give the different type of pieces and the gasket material, and you need to fabricate with the hammer and with the knife the gaskets.
Right.
The gasket. All right, my friend. We hope you enjoy this video, and we are ready to start with the next coming chapter.